Hello, good morning, good afternoon, good evening, depending on which part of the world you're tuning in from. Welcome to the next episode of the OLI Conversation with Experts. This is a 10-minute video recording of a informal conversation with an OLI expert that we feature on a monthly basis. And today it's my distinct pleasure to welcome Dr. AJ Gerbino, our Vice President of Product and Client Success at OLI. And he will be talking to us today about water and wastewater treatment and how the science of electrolyte and water chemistry can really help us to enhance the effectiveness and efficiency of water and wastewater treatment processes. Specifically, he'll talk to us about adsorption and ion exchange processes. So with that, very warm welcome to you, Dr. Gerbino. Great to have you on.
Thank you, Vineeth. I'm glad to be here.
Excellent. So to kick off the first question here, what do we really mean by adsorption and ion exchange, and why are they important? Can you give us some context as it relates to the entire water, wastewater treatment area?
Sure. Yeah. Adsorption and ion exchange actually represent two aspects or different aspects of the same idea. And that idea is, the reaction that takes place at like a solid liquid boundary or surface, or even at a solid vapor interface. Adsorption actually is the process whereby, let's say, a mobile species gets attached to a surface, or let's say a given material. And adsorption can include things like gas molecules adsorbing onto activated carbon, right? Or it could be a different type of process where maybe an ion in water attaches to a clay surface. That would be the ion exchange part. So adsorption is like the larger story, and the ion exchange is an example of that. And you asked why they're important. Well, adsorption is important for a lot of reasons. It's from a water treatment standpoint, it's critical for separation or purification of streams and materials. For example, the first example I want to give is not in water treatment. It's actually something that we're familiar with. Activated carbon. Our activated carbon is used, let's say, to remove maybe bad odors from a refrigerator, or let's say from your house. And that's an adsorption type reaction. Another reaction that everyone may be familiar with are your water softeners in your house. Most often those are ion exchange resins. And those resins, what they do is they absorb calcium and magnesium from the water. And now what that does is prevents mineral scaling of things like your household water heaters. So adsorption is important, not just from the, in many ways, from the home all the way to the industrial sector. Okay, and by the way, ion exchange is just one form of adsorption. There are many types of adsorptions. Corrosion actually is a process that occurs on the interface, and there is a component, there's an adsorption component to that. Electroplating is another type of adsorption reaction. Also, catalysis involves certain adsorption reactions. So hopefully that gives you an idea of where adsorption fits in the story, and also where ion exchange fits. And ion exchange is actually an important type of adsorption reaction.
That's really very helpful. Thank you. The next question is, can you kind of go a little bit deeper into some common industrial applications that use adsorption and ion exchange? And, how are these technologies used in the application? Can you tell us some specifics would be helpful by industry or use case?
Sure, yeah, and we'll focus mostly on water treatment, but it's adsorption and adsorption reactions are occurring everywhere in nature and also in chemical plants or process plants. It's just ubiquitous because it's what happens at the solid liquid interface. And sometimes the adsorption is used to achieve a goal, like to separate arsenic from water, or to remove arsenic from drinking water. Sometimes it's actually an unwanted consequence of a process. For example, you happen to form magnesium hydroxide maybe in a process, and in doing so, you may remove things like borate materials. You may want boron, in fact, may be one of those elements that you want to sell, but because it's being absorbed onto magnesium hydroxide, you may lose some of your product. So as I start talking about these examples of how they're involved with the industry, it's important to recognize sometimes it's a desired reaction, sometimes it's not a desired reaction. But with respect to things like water treatment, probably the most common adsorption reaction is things like ion exchange, where you're either trying to demineralize water, meaning you're removing calcium, magnesium from water, and you're doing so that if you take the water into a heat exchanger, it doesn't form these mineral scales, which you then lose the efficiency of your heat exchanger. Another type of real critical adsorption reaction is surface complexation, a chemical adsorption onto a surface of toxic materials. And usually the surface is like an iron hydroxide. And these toxic materials can include things like arsenic, selenium, and lead, poisonous elements that in fact need to be taken from drinking water. In other types, so that would, let's say, would be drinking water treatment or water treatment to generate steam. Another type, for example, is the adsorbing of things like silicates from hydrous magnesium oxide, or in this case, it's going to be brucite. At high temperatures and high pHs, a silica can actually adsorb onto magnesium, and in doing so, you can actually remove silicates from your water, which prevents other types of scales from forming. And then you can go down the list of other industries where there are a variety of different types of adsorption reactions. Commonly, for example, just real quickly to give you one or two other examples, in the laboratory, you adsorb and desorb on things like packed columns so that you can perform chromatography. Or in metals and mining, when you mine for nickel, copper, cobalt, and the ore happens to be a sulfide and you grind it down really fine, you then react it with a surfactant. That surfactant adsorbs to that surface, and it changes, in fact, the density of that material. And then, then what you're doing is you create this gas flotation process where those materials then rise to the surface, and the gangue material that you don't want are separated out. So again, there's a lot of places where water adsorption plays a big role in chemical processes. And let me stop there because we can go on for a long time talking about that.
So clearly, this is very, very foundational, right, to many different industrial processes, which is really where OLI plays. And being a company that really focuses on electrolytes and water chemistry, can you talk a little bit about the science behind absorption and how electrolytes and water chemistry really play a role here?
Sure, yeah. I remember years ago hearing the story that all the interesting chemistry happens at the surface, and there's a lot of truth to that. And the reason I bring that up is because when you talk about the science behind adsorption, there are different types of adsorption mechanisms or reactions that can be realized. And we have to make sure that we cover all of as many of them as we can. The two key ones, let's say, are things like physical adsorption, or they call it physisorption, which is a non-specific adsorption type reaction. And that's occurring because there's weak bonding, let's say, between what's adsorbed and the surface. And things like carbon absorption is an example of that. And again, the science of that is a little bit easier to model, but that's the sort of chemistry that we need to make sure that we can do in the software. And then there's a more complex one, a more important one called chemisorption, where actually a chemical bond forms between the species and the surface. And that's generally something that's part of reactions called surface complexation, and even ion exchange can be put in there. So with respect to, let's say, the question you had about the science behind adsorption and ion exchange, we, as a company, our responsibility is to understand those mechanisms, those individual mechanisms, and then help the customer, and then in our database quantify how those mechanisms are going to behave. And that's what we do. And so with respect to how the electrolyte and water chemistry gets involved, we will develop the mechanisms, for example, the surface complexation mechanisms, and then develop the interaction parameters or the adsorption coefficients that allow the chemical reactions to take place as they would, let's say, in the field, okay, or in the environment. So hopefully that answers your question.
Yeah, that's a great lead into the next question here, which is, how can we improve the design and operations of assets and processes by understanding adsorption and ion exchange a lot better?
Yeah, well, as it turns out, the reason why we have adsorption in our simulation is because we're trying to do just that, helping clients get to the point where they can model things more rigorously. And so by developing these mechanisms and by adding these databases, we are able to then give the user the tools they need in order to model it properly. Now, I mentioned ion exchange and surface complexation, and there's also something, carbon absorption, weak bonding type of reactions. Where OLI is at different levels of development for that. Adsorption by carbon, by surface complexation, we actually have a very well-developed model with a database, and the customers can use it out of the box. So we're all set up for that. Ion exchange, we have the chemical reactions already set up. All the customer needs to do is bring their resin and their selectivity coefficients to the calculation, and then they can model ion exchange. Carbon absorption, we started developing that, and in the near future, we'll be able to do the physisorption part of the process as well. But that's more things like gas absorption onto, let's say, activated carbon. That's a common example of that. So right now, again, our responsibility is to provide the particular tools that the customer can use in order to develop their model, and then we provide, and we have done that. We've provided surface complexation modeling, we're providing ion exchange modeling, and in the near future, we'll have carbon absorption as well.
That's great to know that OLI has a fairly comprehensive solution for modeling this phenomena, for treating water, wastewater applications. Would you say something about OLI is something unique or differentiated about what we bring compared to other solutions in the market?
Sure. Yeah. The mechanisms of ion exchange and surface complexation, for example, and I'll just talk about those two. Sure, you can do those calculations even by hand sometimes, but the point is to create a complete mass and energy and chemistry balance in one process is really what our goal is, or what anybody's goal is, because it's only when you look at the whole process can you look at optimizing either your yield or minimizing cost or minimizing heats or energy requirements, and essentially providing a holistic type of solution. So what OLI's unique identifier in this case, or a differentiator, is that we provide the complete solution for water treatment. So you can include adsorption with reverse osmosis membrane reactions, with precipitation reactions, with vapor-liquid equilibrium or stripping reactions, all in the same tool. So you've got the complete suite of processes that are important for water treatment.
Excellent. So that really enables that truly rigorous and accurate simulation of water treatment processes for a wide range of conditions. So
that's right.
That's very, very helpful to know. Where can our clients and prospective clients get more information on what we are doing in this area?
Yeah, there's a lot of different points that you can select, or where you can get this information. You can talk to OLI staff about it. Most of us are versed in this area in this field of science. There are videos that we've developed to talk about some of these mechanisms. There are manuals, training materials, where we actually go through the chemical reaction and then show the customer or the user then how to do their own calculations. So there's a lot of ways that you can actually get this type of information. And the nice thing is we all love talking about it. So they should never feel uncomfortable about bothering us about, well, how does this work? Because it's in fact something we enjoy doing.
Excellent. So thank you so much, Dr. Gervino. This has been a real pleasure learning more from you about adsorption and ion exchange. And for our viewers, if you want more information, please go to our website, www.olisystems.com. In the resources section of our website, you can find a lot of information on our blogs and white papers. And if you want to email us, please send an email to sales@olisystems.com for further information. Thank you so much and have a wonderful day.